One way to solve your roots is to use the quadratic technique. And what that means is that I'm going to be using the quadratic program as much as I can in order to solve for my roots because, well, I know you guys don't like factoring. I know you guys don't like graphing. And using the quadratic program is probably one of the easier ways to do this. So again, we're using quadratic techniques. So what that means is our whole goal is to get so our form is in the form of ax squared plus bx plus c equals 0. Now, this may seem a little tricky at first because we're dealing with exponents that are higher than a square. So for instance, for the first one, let's say I have x to the fourth minus 7x squared plus 12 equals 0. Well, okay, so I'm working with a 4 here. I can't necessarily see the quadratic yet, but if I pull that out and look at it as x squared squared, then I know that's x to the fourth minus 7x squared plus 12 equals 0. So notice here that our exponents are 2, 1, and 0, just like it is up here. It's just this time our x is really denoted with the x squared. Well, now I can use my quadratic program and see that the solution, so a equals 1, b equals -7, and c equals 12. So when I plug that into my quadratic program, they give me a positive 4 and a positive 3. Well, now I'm going to set that up. Normally we would say x minus 4, x minus 3. But x is really x squared now. So I have x squared minus 4 times x squared minus 3, and that equals 0. So now I need to solve for both x's in this case. So I have x squared minus 4 equals 0, and x squared minus 3 equals 0. So I'm going to go through and go ahead and solve this. X squared equals 4. X then has to equal plus or minus 2. On the right side, x squared equals 3. Therefore, x has to equal plus or minus the square root of 3. So now I found all 4 roots. There will be times when it might be to the fourth and you only have 3. That just means that you have 1 that's imaginary. Just to kind of double check to see, how many roots you should have, you can just plug it into your graphing calculator and figure out, okay, how many times is it across the x-axis. So this one is a degree to the fourth. Let's look at something that's a little bit different. Let's say, for instance, I'm going to have a fraction. So let's say I have x to the 2/3 minus 9x to the 1/3 plus 20 equals 0. Okay, so this one I'm dealing with fractions. I know that it has to be something squared on the outside. Well, in order to get 2/3, it's going to be a 1/3 inside. Remember, when you have an exponent to a power, you're multiplying. So it would be 2 times 1 to give you that 2/3. So then minus 9, x to the 1/3 plus 20 equals 0. I go ahead and plug that in, and I see that I have a positive 5 and a positive 4. So I'm now going to rewrite this. So I have x to the 1/3 minus 5 times x to the 1/3 minus 4 equals 0. I'm now going to split this. And solve for x. So I move the 5 over. To get rid of that 1/3, I'm going to take it to the power of 3. Think of it. remember how I said when we were trying to get to that 2/3, you'd multiply? So it'd be 3 times 1/3 gives you x to the first. So x then equals 125. And over here on the right side, I move the 4 over. Again, I'm going to take it to the third, or to the 3, so that I can get rid of the third. So then x equals 64. So if I were to plug this one into my graphing calculator, how it was when we started, so x to the 2/3 minus 9x to the 1/3 plus 20. If I were to plug that into my calculator, I would see that this graph would only cross twice to know that I only need 2 roots there at the bottom. And I've got one more example for you. Let's say, though, that I have x minus 8 square root x minus 240 equals 0. In case you haven't picked this up yet, the whole goal, or what our x value is for our quadratic program, is generally this one right here. So I know then that the square root of x squared is going to be that front term. Like I said, it's generally with your b, if you can kind of manipulate it in order to figure that out. So minus 8 square root x minus 240 equals 0. So now I'm going to go through and I plug it in, and I see that they tell me the square root of x equals 20 and the square root of x equals negative 12. Now, something to note. Because this is a negative 12, we know that the square root of an x, or a square root of any number, cannot be negative. Has to be a positive. Otherwise, we'd have an I there, and we don't have an I. So we know that this one does not exist. Because of that negative. But instead, I can still work with this the square root of x equals 20. So in order to get x, true x, without the square root, how do I get rid of a root? I have to square it. So I know that this is 20 squared. X then has to equal 400. I've got one more for you. This one you're going to be doing on your own, and then we'll be going on from there. So let's say, for instance, that I have x cubed minus 3x squared minus 10x equals 0. Okay, because this is an odd degree, I'm going to help you out with the first step. Notice each term has an x. I'm going to pull that x out and then have x squared minus 3x minus 10 equals 0. So from here, you guys should be able to figure it out on your own. So good luck. Looking at this, I have x on the outside. I see that when I plug it into my program, a is 1, b is negative 3, c is negative 10. I plug that into my program, I get 5 and negative 2. So we know automatically that's going to be one of, 2 of our answers out of our 3. So we have x minus 5, x plus 2 equals 0. Okay, so we want each set of parentheses to equal 0. So this first one has to be 0. X equals 0, done. This one, because it was a quadratic program, we already know it equals 5. And same with the last parenthesis. So our final answer, x equals 0, x equals 5, x equals negative 2.